Hello and welcome back to the AutoCAD class. I really hope you are doing very well and that you are learning with the help of our videos. In today's lesson, we are going to look at the theoretical aspect of dimensioning. So basically, we will learn everything dimension from the basic components of dimension to the recommended practices and other things that you need to know about dimension. So this video is helpful for students who are learning or studying technical drawing as well as engineering drawing. So if you are ready to learn with me, then let's jump straight into today's lesson. So today's topic, we will look at the introduction. We will also look at dimensioning components, dimensioning object features, and how to also place dimension. Generally, when we talk about dimension, the idea is actually to communicate the design intent. And most of the times, whenever we draw, we want to send it to the manufacturer to be able to manufacture our design part for us. So, for us to be able to communicate to the machinist or anyone who is into manufacturing, we need to be able to approach with the right dimensioning. And so we are going to look at the types of dimensioning, the dimension components we use, as well as how to place the dimension, and also look at the tolerances that are involved before you can actually manufacture your design part. So dimensioning is the process of specifying the part information by using figures, symbols, and note. So there are times where we include general notes or local notes in our particular drawing to communicate design intent. So in this lesson, we will look at the size, location of features. We will also look at the material types, the number required. Then, as we advance and move forward in engineering drawing, we'll look at the manufacturing process, specifically the geometric tolerances and the size that are used in manufacturing. So this lesson is going to focus on the size and location of features, materials type, and number required. So there are different dimensioning systems that we have. We have the metric, which is the ISO and GIS standard, and that is an example of the metric system. We have 32, 32.5, 32.55, 0.5, and please note that it is inappropriate to write a dimension zero point 0.5, okay, with respect to the metric system, as well as even other dimensions as well. The second dimension system we have is the decimal inch system. So examples, you can see it on your screen. Then we have the third one, which is the fractional inch system. In this particular lesson or in our AutoCAD class, we'll be using the metric system quite often. And so anytime I mention the metric system, I'm basically referring to the ISO standard as well as the GIS standard. But we'll be using the ISO for this particular AutoCAD class. Let's look at dimensioning components. So every dimension component include the extension line, the dimension line, the leader line, the dimension figures, and also the note. Under the note, we have the local note and the general note. So every dimension actually has these particular components. And if you are into technical drawing, the right pencil to use for extension lines, dimension lines, as well as the leader lines is the 4H pencil. And if you are using the dimension figures, the notes, the local note, the general note, it's appropriate to use the 2H pencil. Let's look at extension lines. Extension lines basically indicate the location of the object features that are dimensioned. Okay, so let's look from this particular sketch. When we refer to extension line, what are we talking about? So those two lines that came out of the object is basically referred to as the extension line. Sometimes you can have the extension line in this orientation. That is, if you want to dimension with respect to location, you want to locate the hole that is within this particular object here. So this point and this point gives us the location of this particular hole. So you can have extension line also this way, where you want to determine the size between the two particular circles that you see on your screen. So these lines extending out are what we call the extension lines. You can also have the extension line in this orientation. You can also have it with respect to angle. Extension line also indicates the direction and the extent of a dimension and inscribe dimension figures. Okay, so the this line or this particular line is the dimension line, which helps us to identify the dimension figure that would be on. So we have the orientation of the dimension line in this or manner. And you also have the dimension figures centered in between the extension line that you see. Let's look at leader lines. The leader lines basically indicate details of a feature with a local note. So if you look at this particular leader line, it comes with an arrow and a landing line. So the landing line is where the local note will sit and gives us details of the particular hole that we are looking at. Now, it is also important to note that the arrow is pointing to the center of the circle and not just the circumference. So always your leader line arrow should point to the center of the object, whether it's a circle, a fillet. You can also have it in this orientation where the arrow is actually coming from the center, okay, of the circle. And then you have the extension, then the landing line before your local note comes and sits on top. So this is the local note for this particular circle, 10 drill, comma, 2 holes. Then we have the dimension figure for this one, which is R16 or basically radius 16. Let's move on to the recommended practices that we have to note down whenever we are dimensioning. With respect to extension line, it is important to leave a visible gap approximately 1 millimeter from a view and start drawing your extension line. So let's look at what we are referring to. So once you have your extension line coming from the view, it is important to leave this visible gap here. This visible gap should be approximately 1 millimeter before the extension line can follow. Always make sure that you have that gap left over there. And also extend the line beyond the last dimension line approximately 1 to 2 millimeter. Okay, so after you've introduced your dimension line, it's important to also extend the extension line a little bit, approximately between 1 to 2 millimeters. So the red circle here indicates actually the extension length, okay, and it's approximately 1 to 2 millimeters. So these are other examples that you can take note of. Always make sure you have the extension between 1 to 2 millimeters. Let's look at common mistakes that students usually make. Okay, so sometimes you have students having the extension line as well as the dimension line far away from the side that they want to really dimension, and it's important to take note of this and not repeat such mistakes. Extension line: do not break the lines as they cross the object lines. So sometimes in an attempt to beautify your drawing, students tend to have the extension line broken, okay? They break it at a point where it crosses the object line. So once you see something like that, it is wrong. Always make sure you have it continuous. Okay. So let's look at a common mistake that students normally do. So this is a common mistake, and most of the time is because they want to make their work nice and appear good. but it's actually a wrong practice. So do not break, make sure the extension line is continuous. And also the dimension line should not be spaced too close to each other and to the view. All right, so if you have a particular dimension, you shouldn't have the dimension too close to the view. Okay, you are supposed to leave a space of at least two times of a letter height. So the height of the dimension figure, you leave two times of that before you have your dimension figure introduced, then your dimension line and all of that. So these are other examples that you need to take note of. In a case where you have extra dimension following the side of the view, you should leave a space of at least one time of the letter height. Dimension figures. The height of figures is suggested to be 2.5 to 5 millimeters. Alright, so that's the approximation of the size of the dimension figures. And also place the numbers at about 1 millimeter above dimension line and between the extension lines. So this is what we're actually referring to. So this visible gap before or the gap between the dimension figure and the dimension line should be approximately 1 millimeter. And also the dimensions figure size should be 2.5 to 5 millimeter approximately. Let's look at common mistakes. So you have students always or sometimes having drawn their figure, they have this dimension figure sitting right on the dimension line, and it is a wrong practice. Or you have the dimension figure aligned to the left or aligned to the right. And when there is not enough space for figure or arrows, put it outside either of the extension line. So there are times where in your drawing you have little space to be able to dimension, and you usually come across this when you are using your drawing board and your pencil and all of that. That is in technical drawing. But in computer aided design, the software has its way of creating and bringing a dimension for you irrespective of how small the size is. So this is helpful for those who are learning technical drawing. In case you have a drawing that the space is too small, do not squeeze the dimension figure in between the extension line. Always you have to use this approach. You would have to bring the dimension figure outside, and so you leave the space in between there. In a space where you have little space for, or in a situation where you have little space for arrow, you have to make sure the arrows are outside so that you don't put all the arrows together. Let's look at what I'm trying to say. So in this example here, you will see that the two arrows are coming together because there's limited space here. So always do well that you don't um, repeat such mistake. So you're supposed to bring the arrow outside, or if possible, even the dimension figure outside. Let's look at dimension figures with respect to unit. So the GIS and the ISO standard adopt the unit of length dimension in millimeters without specifying a unit symbol mm. So there are times where you see 35, 20, 50, and if you are using a metric system, there's no need to bring the unit mm because we know that we are using the ISO standard, basically the metric system. And also angular dimension in degree with a symbol of that, okay, placed behind the figure. And if necessary, minutes and seconds may be used together. Let's look at also the orientation with respect to the dimension figures. We have two orientation, which is number one, the align method. And basically the align method helps us to place the figure so that it will be readable from the bottom and right hand side of the drawing. Then the unidirectional method, basically it helps us to place so that they can be read from the bottom of the drawing. Do not use both system of the same or on the same series of drawings. So if you are using the align method, you stick to the align method. If you're also using the unidirectional method, you also stick to the unidirectional. Do not combine both the align and the unidirectional at the same time. So let's look at an example. So the dimension of the lens using the align method. So if you could see, we have all the dimension aligned to the size of this particular polygon. So at the point where the side is inclined, we also have the dimension figure also inclined, that is, it's aligned to the sides. Let's also look at the unidirectional. So if you look at this, you could see that the dimension can be read horizontally. You have the 30, irrespective of how it has been inclined, you still can read the dimension figure very well. So this is the unidirectional method. Then dimension of angles using the align method. So if you have angles that you want to dimension and you're using the align method, this is the best or practice to use. Dimension of angles using the unidirectional method. So if it's unidirectional, then this is how it should be. You should be able to read the dimension, horizontally. Local note. When it comes to local note, we normally place the note near to the feature which they apply and should be placed outside the view. And always it has to be read horizontally. So let's look at this one. We have the leader line, and then we have a note of 10 drill, which means 10 millimeter drill. Common mistake. So normally students place the local note too far away with respect to even the leader line. They stretch it too long before they bring the local note. So it is very wrong. And if you look at how this dimension or the local note is placed, it is placed in the vertical orientation. Dimensioning practices. So in the next slides, we'll be looking at the best practices that we need to pay attention to. Okay, so we have looked at all these things. Let's move to where that's the dimensional practices. We've looked at also the local note. So with respect to the dimension practices, the basic concept is as follows. The dimension is accomplished by adding the size and location, basically the information necessary to manufacture the object. And this information has to be very clear, complete, and facilitate the manufacturing method and as well as the measuring or the measurement method. So let's look at an example. So if you have the design part like the green model, 3D model that we have here, and we want to communicate to the manufacturer or the machinist, we need to indicate the size and location, the size of the holes, the location of the holes, as well as the size of the 3D that we have modeled. So to manufacture this part, we need to know one, the width, depth, and thickness of the part. So the S is representing the size, which is the thickness, or this that's the S denotes the size, and the L denotes the location dimension. So wherever you see the X is basically representing the size. Number two, to manufacture, you need to know the diameter and depth of the hole. So these broken or hidden lines here represent the depth of the hole that you see in the front view. So this is the front view, this is the top view. And the last one, location of holes, you should be able to determine the location of the holes with respect to the size. Let's come to angles. To determine an angle, use circular dimension line having the center at the vertex of the angle. So if you have angles in your model or in your 2D drawings, it is important that you use the appropriate practice. So if you look at the second image over there, you would see the highlighter telling you that this practice is what has to be adopted. You should locate the center. Okay, you should use the circular dimension line, also having the center of the vertex of the angle. Let's look at common mistakes. So these are some of the common mistakes that students make. They just assume any center for this particular circular dimension over here. Let's look at arc. Arcs are dimensioned by giving the radius in the view in which their true shape appear. The letter R is always lettered before the figure to emphasize that this dimension is radius of an arc. So anytime you have the R coming in front of the figure, it's basically emphasizing that this is representing the radius of an arc. So you can have it in this orientation or in this orientation. To dimension figures and arrow, to dimension the dimension figure and arrow head should be inside the arc and when there is sufficient space. Okay, so we should have the dimension figure or arrow, it should be inside the arc where there is sufficient spaces. So let's look at the sufficient space we are talking about. So for the sufficient space for both, so if you look at the first one, we have sufficient space. And if you look at the second one, sufficient space for arrow head only. So you move the figure outside. And insufficient space for both, we move both the figure and the arrow outside in this manner. So in case you don't have enough space, you put both the arrow and also the figure outside. In case you have only space, yes, you can put the arrow inside and the figure outside. But if you have sufficient space where you can put both the dimension and the arrow inside, then you're good to go. Leader line must be radial and inclined with an angle between 30 to 60 degrees to the horizontal. Okay, so the leader line must be at an inclination of 30 to 60 degrees. It's not just an assumed angle. Okay, so it should always fall between this range. Common mistake. So students are used to drawing leader lines that are horizontal or even above 30 degrees or above, 60 degrees or even less than the 30 degrees. So they have the orientation in a horizontal manner or in a vertical orientation, which are both common mistakes that students do make. So these are more mistakes that we do make with respect to dimension leader lines. Use the foreshortened radial dimension line when arc center locates outside the sheet or interfere with other views. Okay, so method one is the foreshortened radial dimension. Okay, so if you have a situation like this is the best method. So we have method one. Then we also have method two where you jog the center, right? And then you bring it to tell us that the center of this is actually very far away. Fillet and rounds. Give the radius of a typical fillet only by using a local note. And if all fillets and rounds are uniform in size, dimension may be omitted, but it is necessary to add the note all fillet and round are RXX. So there are times where you would have fillet and round in a figure, and it's important to always have local note indicating that. So in this situation, we have one round here or fillets, and we have the local note indicating that all fillets and rounds are radius 6.5. So in case you see any round or fillet around, it's basically radius 6.5. So this is the application of a local note here, unless otherwise specified. Let's come to curve. The curve constructed from two or more arcs require the dimension or radii and the center's location. So this is what we are referring to. Let's look at a common mistake that normally we do make when it comes to curves. So this is a common mistake and you should do well to avoid that. Let's come to cylinder. Side dimensions are diameter and length. The location dimension must be located from its center line and should be given in a circular view. Okay, so let's look at the dimension of this particular 3D modeling that you see on your screen. And anytime you are given the dimension, the location dimension must be located from its center line and should be given in a circular view. Okay. Diameter should be given in a longitudinal view with the symbol that, okay, placed before the figures. So if you have a diameter, you should always place this figure and then followed by the dimension figure. So example is what you see. So we have diameter 100, we have diameter 70. Let's move to holes. Size dimensions are diameter and depth. Okay, so let's look at the method. And also location dimension must be located from its center lines and should be given in circular view. All right, so it should we should have the location in this orientation. In case you have a circle and you want to determine the locations, we should always look at it with respect to the plan and not the front view. Holes, this time round small size. Use leader lines and local note to specify diameter and holes depth in circular view through thickness hole. So if you have an example like this, you are supposed to use the leader line and the local note to specify the diameter and also the hole depth. So you can have a diameter maybe XX and indicate the depth. Maybe it is a drill, it is a true hole, etc. Also, use leader lines and local note to specify diameter and hole depth in circular view. So we can have a blind hole in this orientation where we have the diameter XX, Y deep, or XX drill, Y deep, or YY deep. What about large size? So use the extension and dimension lines when it comes to large size. You can also use the diametral dimension line or use leader line and note. Now let's focus on some common mistakes that we need to avoid. Okay, common mistakes that we need to avoid. So these are the common mistakes. If you look at the first one, With respect to small size, we have the secant r-axis, and if you look at this one, you realize that the arrow is not pointing to the center. We've said that it should point to the center. Let's move to chamfer. Use leader line and note to indicate linear distance and angle of a chamfer. So this is an example. So for example, if you have a chamfer of 45 degrees, you're supposed to use the leader line and also the linear distance, or the note to indicate the linear distance and the angle of the chamfer. So this is the orientation, okay? Always take note. This is the orientation when it comes to chamfer. So we have this example here. This is the angle of the chamfer. Then we also have the size here. This tells us the size as well as the angle. Okay. And then also for 45, this is the orientation. You can have it this way or that. Rounded end shapes, dimensions according to the manufacturing method. So let's look at how the examples are as well as some common mistakes. Let's look at placement of dimensions. Placement of dimensions. You have some slides to cover. Then we'll come to the end of our presentation or lesson for today. So the last slides that we'll be going through is the placement of dimensions. How to place dimensions. Recommended practice. Extension lines, leader lines should not cross dimension lines. So always make sure that the extension line is not crossing. In this orientation, we have the extension line crossing the dimension line. And it's a very wrong practice to do. Leader lines should also not cross the dimension line. So you have the poor presentation of this. So this is a very poor presentation with the circle indicating that's a poor presentation. So the blue shows us the right way to do. So this is the right orientation. Okay, you can have the leader line crossing the extension line, but not the dimension line. Let's move to the next recommended practice. Extension line should be drawn from the nearest point to be dimension. So it should be drawn towards the nearest point to dimension, not too far off. Okay, so this is an example. So this yellow is very poor. Okay, the right hand side is the good approach to go. Extension lines of internal features can cross visible lines without leaving a gap at the intersection point. So again, this is a very wrong approach. You're not supposed to leave a gap. We've said it in, I think, the previous practices or recommendation that we saw earlier on. Do not use object line, center line, and dimension line as extension line. This is very, very, very important. You're not supposed to use the object line, center line, and dimension line as an extension. So the ones you see here, okay, the this is a very poor presentation, and this is the right presentation to go. You're not supposed to use the center line and the dimension line as an extension lines. Okay. So again, this is the right orientation and the right practice that you are supposed to adopt. Avoid dimensioning hidden lines. So in case you have hidden lines in your drawing, do well to avoid dimensioning it. It's a very poor presentation. So again, the left hand side shows us this is the hidden line and you have a dimension here, and it's very, very wrong. Placing dimension outside the view. Okay, so you're supposed to place the dimension outside the view, provided the it gives it's not able to give clarity. So place the dimension outside the view unless placing them inside improve the clarity. So in a situation where you have this, always do your possible best to bring the dimension outside. Let's look at number 6. Place dimensions outside the view unless placing them inside to improve clarity. So this is also the continuation of number 5. Okay, let's look at this. Even though this is okay, but this is better. So if you look at the other one, it's about clarity here. Okay, when it comes to this approach is about the clarity, ability to see clearly and be able to read the dimensions very, very clearly. Apply the dimension to the view that clearly show the shape or features of an object. So that is a poor presentation. Make sure that you apply the dimension to the view that clearly show the shape or feature of an object. So that is very wrong. The yellow one. The good way is what you see on your screen with respect to the right hand side. Dimension lines should be lined up and grouped together as much as possible. This is also very, very important. You should do very well to group the dimension to make it more presentable and clear. So if you look at the left hand side, again it's very poor. All these dimensions can be grouped to form a chain or baseline. So so this dimension is trying to use a baseline, trying to combine chain and all of that. This is very wrong. This is the right way to do it. And do not repeat a dimension. So this is the last slide. Do not repeat dimension. So this is mostly is an error that you see students repeating when they are dimensioning in projectional views, because you dimension with respect to the front view, then you see another dimension, the same dimension appearing on the side view. So always do your possible best not to repeat dimensions. So guys, this is a very poor practice. The right hand side is the way to go. So all too soon we come to the end of this lesson, and I hope you learned a lot. I'll see you in the next video.